Good afternoon, dear student. In this class, we are going to discuss about a concept of a collision. So, collision, in that there are two kinds, elastic and inelastic collision. So, here the first thing is collision. What do you mean by collision? Collision, it is a physical striking between two bodies is called as collision. It's a physical striking between two bodies is called as collision. So here there are two kinds of collisions are there, that is elastic collision and inelastic collision. So here the first one is elastic collision. So it is a collision in which both momentum and kinetic energy both are conserved is called as elastic collision. It is a collision in which both momentum and kinetic energy is conserved is called as elastic collision. So we know that conservation of momentum and also conservation of energy. According to this conservation of momentum, the collision momentum before collision is equal to momentum of a final collision is called as conservation of momentum. So here kinetic energy. So in a isolated system, the energy should be conserved is called as conservation of kinetic energy. So here this is called elastic collision. Example for this, collision between atoms, molecules and subatomic particle is called as elastic collision. So now let us move on to the inelastic collision. So it is a collision in which here both momentum is conserved but not a kinetic energy. So it is a collision in which the momentum is conserved but kinetic energy is not conserved here is called as inelastic collision. So example for this, the collision between vehicles is called as inelastic collision. So what are the characteristics of elastic collision? Here the characteristics of elastic collision is the both here the energy of this system is conserved, and also here the momentum is conserved. And also kinetic energy is conserved. But here the characteristics of this inelastic collision, here only momentum is conserved This is the characteristics about elastic collision and inelastic collision. Next, another one is there, that is completely inelastic collision. Here, the next one is completely inelastic collision. So here, completely inelastic collision, it is a collision in which the collision takes place between two bodies, strike and move together after a collision. It is called as completely incomplete collision. It is a collision between two bodies is strike is stick and move together after collision. So it is a collision between the two bodies is stick and then move together after a collision. It is called as completely inelastic collision. Example for this, collision between proton and electron. Is the best example for completely inelastic collision. So next one is one-dimensional collision. One-dimensional collision or head-on collision. Head-on collision or collision in a one-dimensional. So it is said that collision between two bodies is initial and final velocity of two bodies is moves in the same straight line is called as collision in a one dimension or head-on collision. It's a collision between two bodies of initial and final velocity of two body moves in the same straight line. Same direction in a straight line is called as head-on collision or collision in a one-dimensional. Now let us derive the expression for initial and final velocity of a one-dimensional elastic collision. Expression for initial and expression for final velocity of a in a one-dimensional elastic collision of a body. So now let us derive the expression for final velocity of a one-dimensional elastic collision. So let us consider a body, two bodies of mass, this is A, this is B, of mass m1, of velocity, initial velocity u1, mass m2 and initial velocity u2. This is before collision. So and after collision, again the same body A moves with the final velocity v1 of m1 and another body B of velocity v2. This is after collision. So here let us consider a two body of mass m1 and m2 of initial velocity u1 and u2. Here also two bodies with a final velocity v1 and v2 of mass m1 and m2. So now we know that the conservation of momentum, according to this law of conservation of momentum, this is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So this is called it as equation number 1. So here simplify this, m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. So take the common term m1 u1 minus v1 is equal to, here m2 is the common, v2 minus u2. So this is expression number 2. Now we know that the law of conservation of kinetic energy, according to the law of conservation of kinetic energy, this is about conservation of momentum, law of conservation of kinetic energy. So here of m1 u1 square plus of m2 u2 square is equal to of m1 v1 square plus of m2 v2 square. So according to the conservation of kinetic energy of before collision is equal to the kinetic energy of after collision. Therefore here initial velocity and final velocity. Now we have to simplify this. So 1 by 2, take 1 by 2 as common term in both sides, m1 u1 square plus m2 u2 square is 1 by 2 m1 v1 square plus m2 v2 square. So in the both sides half is same, so cancel each other. The remaining thing here m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Here also transfer this equation. So here m1 u1 square minus m1 v1 square is equal to m2 u2 square minus m2 v2 square. So sorry, here m2 v2 square remaining here. This is u2. This is m2 v2 square minus m2 u2 square. So here m1 is common, u1 square minus v1 square equals to m2 v2 square minus u2 square. So this is called as equation number 3. So I am dividing equation 3 by 2, we get here m1 u1 square minus v1 square divided by, here in the left side, m1 of u1 minus v1, here right side v2 square minus u2 square whole thing divided by m2 of v2 minus u2. So here m1 m2 cancel, remaining u1 square minus v1 square divided by u1 minus v1 is equal to v2 square minus u2 square divided by v2 minus u2. So simplify this equation, we get simplify that. This is in the form of ax square minus b square form. So a square minus b square can be simplified as a plus b into a minus b. So this can be written as u plus v into u minus v. U minus v into u plus v divided by, sorry, here u1 v1. So here u1 minus v1, that's equals to here v2 minus u2 into v2 plus u2 divided by v2 minus u2. So here these things get vanishes, remaining u1 plus v1 is equal to v2 plus u2. So here we need to simplify v1 equals to v2 plus u2 minus u1. So we get the value of v1. Substitute this v1 value to equation number 1. Equation number 1 becomes m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here we need to substitute here m1 of u2, sorry, here v2 plus u2 minus v1 plus m2 v2. So in the left side m1 u1 plus m2 u2. So simplify this equation, m1 u1 plus m2 u2 is equal to m1, sorry, this is m1 v2 plus m1 u2 minus m1 v1 plus m2 v2. So here coming to this term, come to this m1 u1 plus m2 u2, this m1 v1 minus m2 u2 equals to m1 of v1 plus m2 of v2 here. So here two times of, so here observe this, sorry, this is not v1, this is u1. So here this term goes to here, this is u1. So this is not v1, this is u1. u1, this is u1. Sorry, this is v1, right? This is u1. So here there are two terms here, m1 u1, m1 u1. So here two times of m1 u1 plus m2 u2 is equal to m of, this is, so simplify here, m1 u1 plus m2 u2 equals to m1 of v2 plus v2 minus v1 plus m2 v2. So here just clarify this. So rearrange this equation. So here, see here. So 2 times of m1 u1 and remaining here u2 is the common term. Take it outside u2. Remaining m2 minus m1 is equal to, here in the both term v2 is common. Take it outside, v2 of m1 plus m2. Therefore v2 equals to this term divided by this term. This is the final velocity of a body of B, and another one is there, that is v1. So interconvert this suffix of this term, we get a v1 values. So here we know that v2. So here we need convert suffix, we get v1. So v1 equals to, in the place of 2 we place 1, in the place of 2 we place 1. So we get the value of v1. v1 equals to 2 times of m2 u2 plus u1 of m1 minus m2 divided by m1 plus m2. This is the final velocity of a body A and B. A and B in a one-dimensional elastic collision.